All right, moving on to trigonometry, unit 4 in Math 40S Essentials. Please go ahead and put your name at the top, like always. So this is our 4th unit of 8, so almost halfway through. So let's move on to the first little section here. So trigonometry. We are Ethan. He's installing a home theater system in Swift Current. He places the speakers to get the best sound. He marked angle where the viewer sits should be between 44 and 60 degrees. So he measures out where he will sit 8 feet away, and he wants to figure out the angle. Estimate. Do you think the speakers in the photo are placed correctly? Explain. Well, let's give you some notes then. No, the angle that is marked from the viewer to the 2 speakers looks greater than 60 degrees. The viewer angle to the 2 speakers is greater than 90 degrees. B, why can Ethan not use the sine, cosine, and tangent ratio to calculate the angle? There are no right angles in the triangle. To use the sine, cosine, or tangent ratio, you need a right angle. So if you remember from the previous grade, I think grade 11 and 10, and if even believe in 9, you were given SOHCAHTOA, you're given a right angle triangle, and you have to find opposite, hypotenuse, adjacent using SOHCAHTOA formulas to find out angles and things. Well, if you're not dealing with right angle triangles, and there's usually a little box right here to signify that it's a right angle. If you're not dealing with a right angle triangle, you have to use what we're going to learn in this booklet. So, getting started, we're going to need a scientific calculator, as always. You'll be using trigonomic functions in most of this chapter. Also in this chapter, at the very back, is a formula sheet that I've attached, which looks like this. If your booklet does not have it, please write these down. So, law of sine is this top section. Cosine law, these are the formulas. Then we have SOHCAHTOA. Triangles add up to 180 degrees, so you can always figure out the third section of a triangle by knowing the other 2 and just subtracting from 180. And this is kind of how a triangle is broken down. Big A, little a is across from big A. Big C, big B, little b. This is what you use to fill in these formulas or these formulas. So the booklet will go over first sine law and then cosine law later, and then a mixed version. But from now, let's start with getting started. So solve for n. N's by right here on the left, so we have to isolate it. To do that, you have to get rid of this 12 on this side. Since we're dividing by 12, the opposite of dividing is timesing. So I know that I can times this whole side by 12. When I do that, a 12 divided by 12, well, 12 over 12, if you put it in your calculator, let's do that actually just to show you I'm not crazy. 12 divided by 12, it's going to be equal to 1. Equals 1. So anything over anything equals 1. If you have 10 over 10, it's 1. So you can actually just cross them out. So you're left with n by itself equals, so we brought the 3 over 2 down. Why is there a 12 here? Well, whatever you do to one side of the equation of an equal, you got to do to the other side. So I put a 12 here to get rid of this 12. That means I got to bring the 12 to this side as well. Now, n equals 3 divided by 2 times 12. Well, plug that in your calculator, you're going to get 18. Okay, same thing with this one. N over 6 equals 5 over 4. Well, I'm going to times both sides by 6. These 6's cancel. So now I'll have 6 times 5 divided by 4, which is 7.5. That's how you do those types of problems. And this is introduced as early as, well, as late as grade 9. I know for sure you do grade 9, you do this kind of rearranging and formula stuff, because I just did it today with someone in grade 9. You might even do this in grade 8. I can't remember, but for sure in grade 9. So if it's been a while, then don't worry about it. We'll get there. We'll learn. So number 2, 3 trigonomic ratios are sine, cosine, and tangent. Record each trigonomic ratio below. So what deals with opposite over adjacent? Well, OA, I know from TOA, I remember that. So it was TOA. TOA, tan. AH, cos. OH, sine. That's how I remember it, SOHCAHTOA. And those are the formulas for sine, cosine, and tangent. Is opposite over adjacent, adjacent over hypotenuse, and opposite over hypotenuse. If you can't remember that, you can also write it this way. So you go SOHCAHTOA. And you might have seen this before. So the wheel, if you're looking for the sine, it's opposite divided by hypotenuse, which is what we have here. If you're looking for the opposite, it's sine times hypotenuse. If you're looking for the hypotenuse, it's opposite divided by sine. So same with these, always dividing up and down and timesing this way. This is kind of a cheat that I've used throughout the years just to remember the formulas easier. Or you can just use these formulas or look them up, whatever is easier for you. So 3, we have solve for C to 1 decimal place. Hint, there are various ways to round. Chapter 2 shows how to use decimal places and significant digits. We won't worry about that because sig figs aren't super important. For chapter 9, the number of decimal places in the answer should match the number of decimal places in the given data. Okay, good to know. So solve for C to 1 decimal place. Okay, sine 35 equals C divided by 8.0. Well, to get rid of this 8.0, we got to times by 8.0, which is what they are going to do. Those equal 1. That means I got to times by 8.0 on that side. So what is the sine of 35 times 8? Okay, so your calculator, if you don't know, there's sine, cosine, tan. Every calculator has that. What we're going to be doing here, sine of 35. So I'm going to go bracket sine 35. So I'm closing the brackets. Let's just see what that equals. 0.573. So yeah, it's always a decimal. Times 8 is equal, what's it, 4 point something, I bet? 4.6. Let's round it up. 4.6. So 4.6 units. Solve for C over here. So when you have C at the bottom here, what you can do, they're going to show you how to do it maybe a longer way. What you can do is just switch these two back and forth. So cos 50 can go on the bottom, C can go up top. If your C is always on the bottom, because you want it to be by itself and you don't want it to be underneath anything. So you can just flip them. What they're doing here is timesing C by C, so you get rid of them. C is over here, then you have cos 50 degrees. Then they want you to remove cos 50 from this side by going divide cos 50 of both sides. So now you have 12 cos 50. Either way, you're getting if you flip them, it'll be 12 over cos 50. So C equals 12 over cos 50. So how do we do that on the calculator? Let's do it. 12 divided by, I'm going to bracket it, cos 50, close the bracket again, because however many opens you have, that's how many closes you have to have, equals 18.7. 18.7 units. Good. Moving on to 4. What is the measure of each angle? Okay, so now we dealt with sine 35, cos 50, that kind of thing. In this chapter, you're going to have to deal with inverse. Sine with a -1 or cos with a -1 means the inverse, and that's taking a decimal and changing it to a degree so that we know how big a triangle would be. Let's see the hint here. In this chapter, calculate angle measures to the nearest degree. This is the precision you get when measuring with a protractor. Okay, so I'll show you on the calculator how to do that. So it's a sine inverse of 0.8660. So we have to put sine inverse. If you can see on the calculator, we were using sine cos tan just normally and writing in a number. Now the inverse is actually above it in a different color. So different calculators have different options. It's light blue up above it. So we're dealing with sine inverse, which means to get to that light blue, you have to click the light blue button. So I'm going to go ahead and click the light blue button and click sine inverse, and it'll show sine to the -1, and then it's ready for us to plug in. And it's 0.8660. Oh, 0. Close. After closing the bracket, I click equals, and it's going to give me a nice number, and it'll be a degree, like, there we go, 59.999. So that rounds to 60 degrees. So 59.99 rounds to 60 degrees, and that is a measure that we can use for a triangle. When you're calculating later on in this book, always round to a full degree, and you want it to make sense. If you get 0.001 of a degree, something's wrong. It'll always be like 10 or 15 or 30 or 37 or 43, something like a nice number, not decimals. Okay, let's do this one. Second function, cos of 0.7071. Close bracket. Enter. 45 degrees. 45.0, so just 45 degrees. Awesome. Okay, moving on. What is the measure of each angle? So we're looking for sine A, so the angle equals 5 divided by 9. So angle A equals the inverse sine of 5 divided by 9. So what they did is they sine this to get sine on this side, and instead of leaving it upside down, they just put sine -1. That's kind of a math thing. So instead of having 1 over sine, they just made it sine -1. That means the same as that, which is what we did here, which just means that we can use sine inverse on our calculator to figure this out. So let's do that. Second function, sine 5 divided by 9 equals 34 degrees. Let's round up. Okay, let's go to the next one. 3.5 over 8.3. Second function cos inverse is 3.5 divided by 8.3, 65 degrees. And the last one. We don't even have to divide anything. They just give us a number. So the inverse of 9898. So sine inverse, second function sine inverse of 0.9898. And that equals 82 degrees. Good. Number 6. What are the missing angle measures in these triangles? Record the angle measures on the diagram. Okay, we know each triangle has 180 degrees in it. So we know if we add these and subtract them from 180, we'll get our answer. And our answer, 180 minus 62 minus 36, is 82. 82 degrees. So that one was not bad. This one, we only have one angle. Well, how do we know the other two? This is a special type of triangle. When you see these lines right here, that means that those two sides are equal, which also means that these two angles are equal. So if we go 180 minus 54, we're gonna get 126. Now, I have 126, and I know both of these are equal. All I have to do is divide it by 2 to get each side, which will be 63 and 63. And last but not least, we have one angle and we have to figure out the other two. Well, this one, no idea. This one, there's a box here. What does the box mean again? It's a right angle. Right angles are always 90 degrees. So now we can go 180 minus 90 minus 40, and we get 50 degrees for that one. Excellent. Moving on to 7. Record the given side lengths on the diagram. The side lengths are 2.5, 4.3, and 5. Well, how am I supposed to figure that out? Let's read the hint. The longest side of a triangle is opposite the greatest angle. The second longest side of the triangle is opposite the second greatest angle. Okay, well then let's figure out the angles. So we have 60. This one's 90. That means the other one has to be 180 minus 90 minus 60, 30. Biggest number is 5, opposite the biggest angle of 90, so this side's 5. Second is 60 degrees, 4.3. And then that leaves 2.5 to this side. So that's a cool little hint to help you figure out a triangle. B, the side lengths are 3 point, and 4 point. Well, again, 81, 180 minus 81 minus 55. This side's 44. That means 4.4 is over here because that's big, big. Medium, medium. Small, small. Not too shabby. Oh, feel free to pause whenever you want and try it yourself, and then you'll know the answers coming for this notes stuff. Record the side lengths for ABC at the right. Well, side A, I will dissect a triangle. So in the back on the formula sheet, it shows you how to do this. When you have a big A, the opposite of big A is little a. The opposite of big B is little b. The opposite of big C is little c. So we know side A is 10. We know side B is 11.2. And we know side C is 5.4. that's how you do that. It's not super tricky. And then the last one that we're doing for this section, Marla is leaning a 16-foot ladder against a house as shown to the right. The angle of elevation, that means elevating up from the ground up, is 70 degrees. How high does the ladder reach? So we want to know this from here to here. How big is that? To do this, we have 70 degrees. We have the hypotenuse, which is also conveniently the ladder, is 16 feet. What do we use? Well, we're looking for opposite. Oh, let's do this. So, ka, toa. We have opposite and we have hypotenuse. Which one of these is O and H? O and H? No. O and H? No. O and H? Yes. We're dealing with sine. Sine of 70 degrees is hypotenuse over, or the O over H, which is the opposite, which is the height, over H, which is 16. We want to get H by itself, times 16 on both sides. So 16 times the sine of 70 is the height. Let's do that last one in our calculator here. 16 times sine, not inverse, just normal sine, of 70 degrees equals 15. So the ladder reaches 15 feet. And now we just look at the picture. Does that make sense? If the ladder is 16 feet, does it make sense that it's reaching 15 feet high? It does, because it's not standing straight up, it's angled a bit, so it falls a bit, a foot down. Good. So next video, we'll be going into exploring sine law, and we'll pull out the sine formulas on the back to do that. We'll get into that.